All right, guys, welcome. I hope everybody had a good lunch. Nice, delicious, hearty lunch. All right, so this is talking proximity card access systems or using DSpace to open doors. My name is Brad. Hi. How you doing? I'm not an alcoholic, except last night. So I work for Foundstone. That's a good lead-in, right? I work for Foundstone as part of their open security research project. And so basically that lets me, like most of you guys, play around with cool stuff and tell other people about it. And so as part of that, we use that to enhance our internal methodologies and all that kind of good stuff. So that's what I'm going to talk about today, one of the projects that I took on a little while ago. And basically, I started looking at, RFID systems and was kind of intrigued by like how RFID worked and all that stuff. And Adam Lurie's a super smart guy, and he kind of inspired me a little bit to look at a lot of that stuff. So it was cool. But then I realized there's this whole system behind it. It's not just the reader and the card. And so I started to look at those systems as well. And this talk is kind of the result of all that looking. I'll show you, how things look like between the card and the reader, and then ultimately all of this other stuff that exists behind it. So a lot of people are wondering, like, what is this DSpace thing, man? Does anybody know that reference? Does anybody know this book? Yeah, a couple. All right, cool. So yeah, DSpace is a reference to this book by Daniel Suarez. I don't get money for that, although that is really big, so maybe I should. It's a book called Daemon, and it's really awesome, like techno, like cyberpunk thriller buzzword catchy drama thing that's happening. And it's a really cool book, actually. So part of the book, what they do is all of these people that are involved in this Daemon network all get this like cool this pair of sunglasses, and they see this kind of alternate reality. It's almost like Google Glass to a certain extent, right? So you get to see this augmented reality around you, except in front of you, you see more information about what's around. And as you build points in this world, you get to control things in that augmented space. So it gets really cool. Like you control things, move things around. It's like kind of fun. But then if you become like this super powerful force, you can control things in the space that control things in real life. So like there's this badass guy, Loki, and he controls like this swarm of like killer motorcycle robots. And so like he's just like, kill. And then like he kills a bunch of people. It's great. So, but I really, yeah, exactly, yes. They might actually make a movie of this, and I'm sure they'll do no justice. But I like that idea, right? Like not killing people. I don't want to kill anyone, I promise. But I like the idea of being able, like the internet isn't real, It's like that thing over there that I spend a lot of time on. But when that can interface with the real world and change things in the real world, well, that starts getting really cool and really fun. So whenever I can do that, I like to do it. And so this talk is we're opening doors, literally opening physical doors over the network. And so I like to think of it like that's my own DSpace, like except it doesn't look as cool. A lot more text. All right, so this is what the architecture looks like. It's really simplified. You're probably familiar, starting from right to left, with kind of the really small user with the gigantic card. He talks to a reader, and that happens over RFID, right? And so then that reader takes that value that it's taken from the card and formats it for this WeGAN protocol that it then transmits to this controller. And now the controller holds all of this data. It basically doesn't know who the small user is. He knows what the card value is, and so it knows what that number is, and then associates that with doors and times to access those doors and all that kind of good stuff. And he gets that data from the backend. So the backend is what, like, your security guards or like office managers or whomever who provision the cards, who say, Brad gets this card. That's what they update. And then the backend pushes data to the controller so the controller can allow the doors to open and take data from readers and all that kind of good stuff. The controller can operate without the backend. So if there's ever a network failure or anything like that, the controller can still operate and everything's okay. It even has, kind of a reserve power supply if bad things happen, like power goes out and that kind of stuff. But it depends on the controller. All right, so I decided to, when I started playing around with this, I was like, obviously you need to recreate the environment so you get a real idea of it. So I created this thing. So this is a fancy piece of plexiglass with 2 readers on it, a controller, and then an Arduino. And so the 2 readers feed into the controller, into its reader portions, but the Arduino, it does some other functionality that we'll talk about in a second, but it mainly deals with the door opening. So like I didn't want to buy like a big set of doors, right? And like open, okay, the door is open, yes, like that would suck. So instead I hooked it up to this like clever little light. And so every time a door opens, the light goes off, and then it's like jackpot, yay, like that's fun. So I was doing that, and that was cool. And so so that's the whole setup. So I got here around like Tuesday or so, and I was a little jet lagged, but this setup can be kind of temperamental, so I was a little worried about it. So I wanted to make sure I checked it right off got off the plane. And so I did. I connected everything, hooked up the power supply, everything was going good. And then I went to go plug it in, and I'm like, oh, wait a second, this doesn't compute. I'm American, this doesn't work. What's happening? Circle into square. And so that wasn't working. So I was like, oh, wait, I know what I have to do. I have to use a power adapter, one of these things. So we see where this is headed. So I'm like, yeah, look, Northern Europe, it works. Okay, cool. So I took it, put it in, and then, oh, my God, major issues. So this lovely demo-driven presentation is going to be much less demo-driven because I made the quintessential stupid American abroad mistake of plugging in the wrong power supply into this and basically fried out my Vertex controller. So that sucks a lot. But it's not completely horrible because I have another one, right? Oh, that's good. But it's in New York. So I called up my colleague in New York. I'm like, hey, man, ship this to me. Because remember, this was Tuesday, so there's time, FedEx, that kind of stuff, overnight. So I'm like, ship this to me as soon as you can. He's like, no problem, dude. I'll have it to you. Next day, it should be there Thursday morning. I'm like, all right, awesome. Thursday morning comes around, go to the front desk, all happy. Hey, where's my controller? They look at me like, what? No package. What are you talking about, man? I'm like, oh, no, this is the problem. So I go online and look at FedEx's website, and FedEx says it is delayed beyond our control in France. The demo-driven presentation, again, will not be so demo-driven, but I hope you'll still learn some stuff without the flashiness and the lights not going off. That makes it really fun, and I'm kind of bummed out that I wasn't able to do that, but hopefully it'll still be interesting for you guys. All right, back on topic. So the card-to-reader interface. So you have this card, and the card talks to the reader, and the card, not all cards are created equal, right? So just because it's square and white doesn't necessarily mean they're all the same cards. So they operate over different frequencies. So if you're familiar with RFID at all, you know about 125 kilohertz and 13.56 megahertz. So it's usually one of the two. There could be other ones, but usually it's one of those two. There's also varying levels of security. So some cards have no security, and some cards have some security. And so the security, what I'm talking about, is how the data is stored on the card so that any user can't just, or any person can't just read data off the card. And then also, when the data is communicated, how it's protected. So can the card authenticate itself to the reader? Is that data vulnerable in transit? What's the deal with all of that? And so that's the security level there. So we'll look at two HID procs and iClass. We'll briefly look at iClass. So the procs cards are like the first ones, like one of the first ones. They're the most popular. They're the most widely deployed and the most widely kind of exploited and looked at. Just to give you a brief overview about it, the card itself just contains a number. It's this 26-bit, using the 26-bit card format, it's 26 bytes or bits, and the first and the last is parity bits. And then in between, the card value here is separated into two sub-values. One is this facility ID or site code, and then the other is the card number. So the idea behind this is that a company would buy one of, set the system up, and maybe they would all have the same site code, right? So company Y has site code 10, and then all of their users would be assigned a card number between 0 and 65535. Okay, pretty simple. Maybe if company Y has another branch, a larger branch, they'll assign a different facility code to that one so that they can have their own facility code. And then in the back end doesn't care about facility codes. It just wants to know, all right, what numbers are assigned to you, and then this is how it all works, right? It's pretty simple, pretty basic. The only issue is that the facility codes only go to 0 to 255. And I'm pretty sure there's more than 255 companies in the world. I could be off by that number, but I'm pretty sure there is. So the issue happens is that there could be more than one company with the same facility code, right? And the people who pick who gets the facility code is arbitrary. It's whoever's setting up the system. If they previously, the company previously has one of these deployed, maybe they'll follow what's pre-existing. But if like Bob's security company comes into an office park and decides to set these systems up, Bob could love the number 10 and could just so happen to assign everybody the 10 facility code, and so and that can happen like naturally too. Like maybe I live and work in New York City. There's a lot of companies there. I'm sure there's companies that share the same things. So then you have to also get the same card number, which could be a little bit more complicated. Between 0 and 65535 35 is pretty big, but still possible. So I guess the important thing to recognize here is that there could be two completely unrelated people, from two completely different companies, that just so happen to have the exact same card numbers and can basically go into each other's companies and become that person from a physical access control system, right? So that's like a scary thought. The chances are probably pretty slim, but we'll look at that specific behavior to talk about some attacks. So HID is, and I talk a lot about HID, and I don't mean to pick on them. They're just like the big, they're the big pie in the sky company. They have, they do a lot of this stuff. There are a lot of other companies that implement the same formats and do the same things, but HID is just gigantic, So HID offers some alternatives. So they have their 35-bit, and 37-bit controlled formats. So what that means is they control the numbers. Bob doesn't get to pick the facility code anymore. They pick it, and then presumably they pick a one that's unique to every organization, right? And so they assign them properly and make sure there's no overlap or anything like that. But still, it's a big problem, and a lot of people use these systems. One of our customers, we were running a test for one of our customers, and we're doing some of these attacks, and the customer's like, well, what do I do? Like, all right, you were able to break into our building. What do I do? And we're like, well, you kind of have to replace your system, man. Like, I don't know. And so he's like, oh, well, that's unfortunate because we just put this system in place like 2 months ago. So these systems are definitely still being deployed, and that sucks. So hopefully raise some awareness and people won't deploy them. They'll move to some of the newer ones. All right, so let's talk about cloning these things. So cloning these things is a pretty widely known thing on how to do. Basically, it uses something called the Proxmark 3. How many people have seen a Proxmark 3 or heard of one? Yeah, some? Okay. So this is the Proxmark 3. It'll cost you about $300. It's open source hardware, so you can get all the schematics and build one yourself if you want. It runs on open source firmware, which means you can modify it in any way that you want and do basically whatever you want with it. It operates on it operates on both of the RFID bands that we're going to be talking about, and has a lot of cool functionality. So by default, if you buy this thing for $300, you get this little thing, and then you can buy an antenna. And it comes with firmware that will allow you to clone these cards like right out of the box, right? So it's pretty simple. All you have to do is press a button, and then this would be another demo portion. So I'd press a button, read a card, and then play it back to the reader. And you kind of have to get a little close in practical situations. You kind of have to almost touch someone's butt a little bit, so it's a little awkward. But still, you can skim the card out of their pocket, and then play it back to the reader, and then you are that person, right? It's like copying the keys to their front door, that equivalent. So it's pretty straightforward. And then you can also do things via the command line. And those are the commands down there. So as I started to look at these types of card values, I started to realize, well, the only thing that makes these card values like at all difficult to figure out is the site ID, right? Like that facility code is kind of difficult. So if I figured that out, I'd have a pretty good idea of what card values are active. But then I realized, well, there's that big 0 to 65535 range of card values, and to guess all of those would be kind of difficult. So I started to think. I was like, all right, well, how do you order these cards? So I went online and looked at places to order them from. And the way you order is you provide your facility code, you provide a starting number, and you provide a quantity. And the lowest quantity that you can buy is 100. Well, so that means all of the numbers are all the cards are sequentially numbered, right? If I provide a starting value and a quantity, they're not going to give me like starting value 100 and then 300. They're going to give me 100, 101, 102, 103, 104, 105. And so if I know any one valid card value, so this could be a disabled badge, a lost badge, a temporary badge, a badge you just read off somebody else. If I know one valid card value badge, I can guess other valid card value badges. And so, so if it's a disabled badge, well, I could then guess another badge that's enabled just by sequentially iterating through the numbers. So just trying different values. But if it's a card that has maybe front door privilege but not data center privilege, well, then I can just go up to the data center and try that value and start trying other values and incrementing them or decrementing them to get access and guess a valid value for the data center. So you can do privilege escalation really easily with this stuff. In practice, it takes like seconds to find another valid card value because, again, they're sequentially numbered. So you just basically, like, if you have a disabled card, you go up, wait a second, it beeps maybe twice at most, and then you hear the door unlock, and you're like, all right, access granted, cool, I win. With data centers, it can be a little bit more difficult in higher privilege areas because a less amount of people have those privileges. So it takes a little bit more guessing, but usually under a minute you'll guess it. It's a little bit odd. Like if I were to show you guys the demo, you hear like beep, 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 and then eventually like the door just opens, and you're just like, all right, cool, and then you walk in and you have access. So it's kind of a fun thing, but it's a little attention drawing because you're just standing there and the door just keeps beeping. We had one of our guys was on site, and so like sometimes it could take a little. So it took him like in this particular instance, he told me it took about 5 minutes. And so after the first minute, he was kind of getting tired of holding the antenna up there. So he took a thumbtack and thumbtacked it into the wall to hang the antenna over the reader like this, and then just kind of stood there like just waiting. And he said people like walk past him, he just give them a wave, smile. They just keep walking. Nobody like. I mean, how obvious can you get? Like you have a thing over the reader, it's beeping. The guy's like, I don't know. So, but that's the kind of ridiculousness that happens. So this is pretty devastating. I mean, if you think about it, you can, as long as you have one value, you can do it. No knowledge brute forcing is much more difficult because you have to guess. Usually, what you do is you guess in big chunks. So, like for facility code 1, you try like a number between maybe 1 and 500, and then 500 to 1,000, and 1,000 to 1,500. And each guess, it takes about a second. So, I mean, to guess the brute force the entire key space would take like, I don't know, like 3 years. And I'm sure like after the first year, somebody's going to notice you there. So, I mean, you got to be careful. But still, I mean, you could still do some intelligent brute forcing to help out a little bit in that, but it's kind of hard. This is something I thought was kind of interesting. So I was ordering all these parts on eBay. And now keep in mind, if I know your facility code and if I know your card number range, like I have the equivalent of the keys to your house, right? So this guy, and it's just lack of knowledge, right? People just don't really understand it. So this guy like puts them up online, and he's like, hey man, I accidentally ordered some duplicates, so here are the excess. And then like the facility code and the range is on the bottom. Just like, what are you talking? What are you doing, man? It's not a good idea. So like if you could figure out where the seller's actually from, you can basically go there to his building and use those same excess cards and then just try to read one at a time to see which one was available. Unless maybe, you know, he ordered, instead of ordering like 200, he ordered 500, and these are the 500 that aren't used. That could be it too. But either way, you know, at least I know a number in the range that I can guess at, right? Stupid. All right, let's talk about I-class cards. So I-class cards, so we talked about the prox cards, and the prox cards have that value on them, and no security, meaning that anybody can query it and anybody can imitate it. Really simple. I-class is a little different in that it still stores that value, but it, like, you know, puts that value in a safe, you know, and protects it. So it has it's a full-on smart card, contactless smart card in there. And there's two types of I-class cards. There's high security and standard security. So for standard security, every HID reader, every HID I-class reader, and every HID I-class card has the same key. So if you get access to that key, then it's like, you know, gold mine, right? You're now at almost the same level as you would the prox cards. Okay, for the high security, you define your own key, so that makes it a little bit more difficult. You still have to gain access to the keys, and you know, once you get the keys, it's good, but it's much more difficult to get the keys because with standard security, I can buy any HID I-class reader and pull the keys off of it. For high security, I need to get your I-class reader and pull the keys off of it. So how do you pull the keys off of it? Well, so up in the upper left, Milos and Henrik gave an awesome talk at a couple of CCCs ago. And what they did was like awesome stuff, right? Like they pulled apart the reader, and then they did the thing where you like cut off parts of the chip and then like look at the gates on the chip to determine how things work. Like, what? Absolutely awesome stuff. But what they did was they determined, so like let's say this is the memory of the card, of the microcontroller that exists in the reader. Okay, so the memory of the microcontroller exists in the reader. What they found is if you overwrite the first portion of it, right? You have the ability to remove certain values, right? So if you kind of delete the first portion or the first chunk of the firmware code and replace it with dumper code, you can replace it and then dump the rest. And then you get another reader and then overwrite the last values of it and replace that with dumper code. And then once it boots up, you can get the whole image. And then with the whole firmware image, you can pull out and extract the keys. All right, it's a pretty good attack. It works pretty awesomely. The problem with it is I have to like destroy two readers, right? I have to like delete stuff on the reader, and like I could potentially totally, you know, make the reader unusable. And so there's some problems with that, and that's a little bit concerning. So this dude from proxclone.com, what he did is he discovered that you can actually get access to the memory of the reader. So you don't actually have to overwrite the firmware itself, but you can get access to the memory that the firmware uses. And so with some instructions, you can pull the keys out of memory after it reads a card. So the problem with that was, though, that although his white paper is pretty detailed, he like implemented it in his own hardware device and then didn't release the like schematics of it. And so like, you know, it's kind of, there's still like a big entry or barrier to entry if you want to replicate this work. So what I did was I used this FTDI TTL232R, which Milos and Henrik used, and implemented the attack that the proxclone.com uses. So now you can use this cable with like an Android phone. You can use the cable with a PC, and literally walk up to one of these readers, unscrew it, get access to the back, the programming interface on the back, plug it in, press a button, and 60 seconds later you have the memory dump, which has all the keys and all that stuff in it too. So now it's like the attack is much more, you know, kind of refined to a certain extent and much more easier to implement. All right, so let's look at the next interface. So from the reader to the controller. All right, so now we're done with all of the RFID stuff, right? All of the RFID stuff, the security there that exists, this is after the RFID portion. Now we're all on the WeGAN interface. So the important thing to realize here is that between the reader and the controller is all this standard protocol, and all cards output from the reader the same thing. So it doesn't matter about the security. It's all the same data that's being transferred from the wire from the reader to the controller. So let's look at that protocol. It can also be RS-232, as I'm pointing out in the bottom, but it really depends on the setup, but most often it's the weekend. All right, so this is the output from a logic analyzer, okay? Weekend is really, really simple. It has two lines, a data 0 and a data 1. They're both always high. Whenever it wants to send a 0, it drops data 0. Whenever it wants to send a 1, it drops data 1. Okay? So really, really simple. I decoded everything in the middle here for you. So you can see, like, this is what it looks like in binary, and then I converted it to hex, and then you can see what's ultimately the site code and the card number that's printed on the bottom of the card, right? So to implement this protocol is super easy, right? I mean, you have two high lines, you just drop them whenever you want to send anything. The kind of annoying part about it is, though, is it's not super elegant. You have to pop off the cover, so you have to do that, and then unscrew 2 screws, and then you have access to the cable in the back. And then you have to kind of pull apart to get access to the actual wire. So it's not super elegant, but once you have access, it gets super easy. Oh, sorry, some nudie pics. I didn't mean to. No. All right, so what I did was I implemented this whole thing in an Arduino. Now, a little while ago, somebody gave a talk at DEF CON, and I added this to the slides because I want to give that guy shouts. He created something called a Gecko, which is basically like a man-in-the-middle almost hardware device for these things. I implemented kind of the same thing with some more features, but he didn't release any of the schematics and stuff, or I couldn't find them. So like, if you guys ever do research stuff, please, like, release schematics, like show people how to do stuff, because otherwise, they have to learn on their own, and that just sucks. So I released all the schematics for all this stuff, but it's just an Arduino. You can look at a picture. So what this does is it does a couple of things. One, it's a skimmer, right? So it sits in line between the reader. So if you want to, you can put it in line between the reader and the controller, and then it will take anything that it reads in from the reader and then just replay it back to the controller. So if you wanted to, you can put, like, a storage device on here and then just have it log everything. So if you're an attacker, maybe you go there at night, put one of these in place, embed it into the wall, close up the reader, come back the next night and get all the card values that were sent over the wire. What you could also do is put like a Bluetooth or a wireless adapter into this thing. So then this way you don't have to actually, like, go into the wall ever again. You can just always check out what's getting skimmed from the device and getting all these card values. So that's always good too. The other thing it does is it emulates too. So if you, I sort of want to see if I can show this, but with all my demo luck, I just feel like everything's going to explode. It's saying door unlocked. Yeah, that's right. There's no doors. All right, so this is the Arduino output. I'm going to see if this works. This is an I-class card. I have an I-class reader hooked up to it, and so I'm just going to try to read it. Oh, good. So this is kind of what you see from the Arduino. It just says, receive the input from reader. This is the binary representation, hex, the site code, and the card number. So it has all that stuff. But what you can also do is, again, imagine if you had like a wireless module attached to this thing. You can just kind of take the value and then just paste it in. And it should, yeah. Well, it's saying invalid input length, of course, because everything else breaks. But you could just paste it in there, and it'll automatically send that value to the controller. So at this point, you don't even need the card, right? All you need is the card value, and you can play it directly to the controller, and the controller thinks it was read from the reader. So if I had a wireless interface, I just walk up to the door, just say, Brad's card, press go on my phone, and then it opens the door, that kind of thing. So that's pretty devastating. That's pretty fun to do too. The other thing you can do is a fuzzer. So I also implemented a fuzzer on Arduino. YGAN has not too many test cases, right? I mean, you just lower data 1, lower data 0, lower both, long strings, that kind of stuff. So I implemented that with a bunch of test cases. So if you wanted to fuzz the controller's interface, you could do that as well. Also, Wigand is used for, or Wigan, it's used for like magnetic stripe cards. It's used in some biometrics. So you can use this Arduino interface to fuzz all of those and to mess around with all of those different types of readers, essentially, like whether it be a magnetic stripe or a thumbprint or something like that. And then also, might as well do a brute forcer too. So I also implemented brute forcer that brought it up from 1 ID a second to 5 IDs a second. The limitation there is there has to be certain spacing between the IDs in order for it to brute force. Otherwise, the controller interprets it as one long string, right? You have to have some spacing in between it. So I can do 5 IDs a second, which is a little faster. You can do some no-knowledge brute forcing, but again, it may not be super fast. But if if you can have it run for a while, maybe overnight, maybe you get something better. And this, again, can all be run via PC, iPhone, or Android. So you can have everything very mobile, very easily accessible. All right, so let's talk about targeting that controller that we were talking about. The controller is, so let's talk about the targeting controller. So the controller takes the data in from the the reader and then formats it for the database, for the backend. So remember that we're going to look at the Vertex controller, this specific one for HID. It's the V2000. This controller is kind of used in a couple of different places. It's sometimes rebranded and all that kind of good stuff. Again, I'm just picking on HID because they're popular, nothing specifically against them. All right, so these things are usually deployed in a building environment, which, with a bunch of them deployed all throughout the building, and they're hooked onto the network. So they have this discovery protocol that's in place. It's a super simple UDP based discovery protocol, it's all plain text. It's like semicolon delimited, like really easy to re-implement. So I implemented a quick discovery tool in Python so that if you're on one of these networks, you can run this tool and get the version information, what IP addresses, and discover what your targets would be if you were to get onto one of these networks and start to mess around with it. All right, so let's talk about hacking this controller a little bit. So when I got it, I'm like, all right, well, there's probably going to be some sort of nice remote exploit in this thing, or something else I can do. But let me just first look at how this thing is put together and how it's supposed to be managed. So I went through the controller, and so all right, to log into it to the UI, I had to log in with the username admin, password blank. So I was like, all right, cool. Log into the web UI. And it asked me to change my password, so fair enough. So I changed my password, and then I did a quick port scan of it and noticed Telnet's open. So I was like, all right, well, let's see what happens when you connect Telnet. So I connected to Telnet trying to use that admin username and password that I set via the web UI, and I was able to get access to it. So I was like, all right, this is great. I was able to get and discovered it's all running Linux. It's a embedded Linux system, and not too bad, right? It's an access board or whatever. So I catted out the password file and discovered that there's this root account there. And so I'm looking back through the manual like, wait, where's this root account mentioned anywhere? Like I don't see this anywhere. Like what's going on with this thing? So I couldn't find it anywhere. So I was like, all right, well, fair enough. Might as well try to crack the password. It's just looking at me. So I looked at it, and sure enough, 3 seconds later, the password cracks, and it's the password of pass. All right. So I was like, all right, well, that sucks for them. That was obviously pretty dumb, bad job. But I was like, it's not that devastating of a finding because people can just change the password. I mean, it is undocumented and all, but you can still kind of change it if you knew so much about it, so whatever. Well, what I later discovered is that a lot of the back-end systems that manage these controllers have this account hard-coded into their application binary. So if you change this password, you would literally break all of your back-end systems. So that sucks, man. Like, you can't change it anywhere. It's like, all right, and the password is pass, like horrible. So that sucks. But I was like, all right, cool. Well, that's a pretty persistent way to get access to the system. I could find there are definitely exploits that are available in it, but those could be patched over time. Maybe they'll change this and then allow you to set the password in the back end. I don't know. But I wanted to start looking at the system itself. So I started to mess around with it, and I realized that what I tried to do, the very first thing I tried to do is I read a card value, and then went to the back end, and the door opened, and then I unplugged the network cable and read the card value again, because I wanted to see how dependent on the back end the controller was. And sure enough, the door opened again, which immediately indicates, all right, there must be some sort of local cache on there, on this controller that I can play around with. So I started to dig through all the files that exist on it, and found these two files, the AccessDB and the IdentDB. So both of these files are just basically big binary blobs of data that contain all of the card values and their access restrictions. So, you know, Brad's card value 123 is allowed to access this door at this time, and that kind of stuff. So, you know, that was pretty good. So I was like, all right, fair enough. You know, you have all of that information in there. So I wrote a quick tool to parse that data out of it, because again, it's not encrypted, nothing special about it, just a big binary blob. So and once you look at it and understand some of the values, it's really easy to pick apart like how it's all delimited and how it's structured. So I wrote this easy tool to parse everything. But then I was thinking, like, wait a second, what am I doing parsing this? Wait, this is a local cache. I can inject into it, right? So what happens if I'm an attacker and I have a card value? Like, I have my own card that maybe works at my company, you know, or just a card I found on the street that has nothing to do with this company. Well, I can take that value off of that card and then inject it into this cache, and the door opens. So that's awesome, right? At that point, because now, you know, I can just walk up and, you know, through DSpace, right? Like, wow, card value, inject, enter, and then, you know, stuff happens. So that was pretty fun to discover. But the problem with that was that in the backend logs, it says user access granted to door blah blah blah, user equals, and then just nothing. Right? So there's still like a log entry. The backend doesn't know, like, I guess the backend doesn't know, like, since it doesn't have that card number in its own database, it doesn't, you know, can't look it up, and so can't populate that value. But there's still like a log entry. So I was like, go ahead. Yeah, for sure. Yeah, so the way the backend works is, so the question was, does injecting work if the backend is live? And the answer is yes, because the backend pushes data to the controllers, to this you know, cache or database, whatever you want to say. It pushes that. So once it pushes it, I mean, there's theoretically, like, over time it can do a refresh where it deletes everything and then pushes up a new value. But still, it definitely does work. Yeah. So you can totally inject values into this database and open any door that you want. Like, I injected a value, gave it full access to both doors, it was able to do everything. So opening doors, part one, good. So I was talking to the guys at work, you know, and I'm like, yo, check this out. I just injected this card value. I'm super cool. Like me. And they were like, no, that's lame, man. Look, there's a log entry. That's just not cool enough. Sorry, we will not be your friends. So I said, all right, fine. Can I buy you more beer? And they said no. So what I did instead is I started to look at how the system actually opened doors itself, right? And realized that so basically each of these outputs to the doors that I have hooked up to the Arduino basically are all controlled by a serial interface internally. So if you send the right command to the serial interface, it triggers the unlock mechanism. So I did like a whole bunch of kind of serial debugging to determine this, and figured out, like, oh man, there's this like generic test utility that comes on the platform called hardware test serial, and you can send arbitrary commands to its serial interfaces. Like, yes. So with one pleasant command, you can execute this command, and the door just opens, and it's just like magic. You feel good. The light goes off when it works. And everyone's happy. So I really felt good about that. That was all via, like, you know, again, more DSpace, no logs whatsoever at this point. So doors just open, right? Yeah, pretty nice. And then the last part was, I was like, all right, well, this web UI, like, you know, I have this root account. It's just like hard-coded. What else can I do with it? Well, I could also log into the web UI with it. And the web UI also offers some functionality. And I determined, like, you can basically open a door via GET request. So if you have this username and password, you set, like, so I wrote a quick Python script to run a GET request. I could have done it in a curl, like literally like a one-line curl thing. and press go, and doors open. It's just like, great, more door opening. So there's like a lot of ways. Once you get access to one of these boxes, you can trigger that door to open like all types of different ways and just make that light always stay on. It's nice. The other cool things about the web UI, and I haven't did the proper amount of serial debugging to determine this, but like with the web UI, I can make a door stay open. Like not only can I just open it, I can just say always stay open. And what's even more scary is I can make a door stay closed, which is really scary. But yeah, so you can also make doors, press the button, door open or close, and then everyone's locked in. Oh no. I was actually really worried about that. It turns out if you pull like a fire alarm, I think they fault open. So if usually there's like an emergency exit button or like a fire alarm thing that makes them open no matter what. So I'm happy about that. All right. So the last part is the back end. So let's look at about like what we can do if so we're done with that controller. We're done with the readers. Let's look at if we target the back end specifically, what sort of information is there. All right. So the backend that we're targeting is called WebBricks. It's a popular one. I kind of picked it only because they had a free downloadable trial. So I was like, all right, I'll use that. And I threw it inside of a VM. It runs in Windows. I think the preferred operating system is Windows 2003. And by default installs with SA with no password. So if you've ever done an internal penetration test ever in your life, you know that that's available everywhere. So they contribute to that. The installation is unnecessarily bulky and annoying. Like it contains like 500 setup.exes, and you have to like click each one in succession, and it sucks. Like it's the worst application ever. And then like, oh man, it was hard. They give you like this login to get the free trial. They give you a login to this FTP site, so you have to call up their customer service and get like, I want a free trial. And they're like, all right, cool. Well, here's the username and password to the FTP site. But the FTP site doesn't just provide like the downloadable software. It also is like what their techs use while they're on site. So they upload like all types of like client information to this FTP site, and so you can get like there was like a ton of different universities where I just pulled like their entire. You can see like every card number, value, everything. Like just total, like, so I told them about it and they never responded, of course, but later on they removed it. But it was just like come on, man, really? Like, what's happening here? Anyway, so the WebBricks, the backend has two major parts. It's a web UI, and that's where kind of all of your system, the security people and everybody who manages the system logs in through. They can associate my pretty picture with my card value and do all of that stuff on that back end. And then the controller, again, just gets pushed that data. And it doesn't get my picture. The controller doesn't care about how pretty I am. All it cares about is the number that I'm associated with. And then there's also this, over TCP 4070, there's also the interface to the controller. And so it implements its own protocol. The protocol is plain text by default. There are ways to encrypt it, but it's like, you really have to like try to do this. It's like not something like just click this button and everything's secure. You have to like do stuff. So that kind of sucks. But the plain text protocol is really easy to decipher. It's a proprietary protocol, but again, it's super simple. It's all semicolon delimited, and without saying anything very specific, if you play with some of those values, there are definitely like stack overflows up the wazoo in the software, and it's just horrible. Like, it's bad. If you're able to sniff that communication, if you're able to get on that same segment, you can see, because it's plain text, you can see all the card values that are going back and forth. So if you're trying to get card values again, you can just pull those out. You can actually inject into that stream if you're in a good spot on the network as well. And that was shown in DEF CON 17 with this open sesame.py. Basically, they used, on a different backend, it wasn't WebBricks, it was a different one. They used TCP sequence number prediction to inject data into the stream and then do things like open doors and that kind of stuff. The web UI is absolutely full with like SQL and all like the web stuff. It's all over the place. Anonymous loves it. But the really fun stuff is kind of the more serious exploits that exist in there. And I still haven't heard back from those guys about it, so I'm not going to disclose any of them, even though it's been like over 6 months. But I have released all of these Peach fuzzer XMLs. So like I know people don't like Peach, but I like to use it to do data modeling. So if I'm trying to reverse a protocol and figure out how things are put together, I use Peach in its nice friendly XML format to make all of that data structure and see what it all looks like. And then the added side is that then I can use that XML to start fuzzing the network protocols and stuff. So I published all of the fuzzer XMLs. You know, if you were so inclined to just basically run Peach with that XML against one of those things, you'd find a lot of fun stuff. And then I also did the XMLs for the discovery process. So if you wanted to fuzz the controller and maybe find stuff there, you can use those XMLs. And then you can look for things beyond that. All right, so that's the presentation. It usually take a little bit longer because we would have this amazing light show. But hopefully it was in your mind's eye every time I said door open. Any questions, guys? Oh, sorry, one. In dollar? So I haven't looked at the MyFair cards, and I think like HID uses like the DesFire MyFair cards or whatever. I've looked at MyFair cards in a different, just for academic, like my own purposes, but not in these systems. But my guess would be because of how everything is dependent on the card values, the MyFair card would actually have the same value that it's still being sent. So it's still, you know, from the reader to the card, there's security, but after the reader, it's all the same. So you can, you know, use those same YGAN tools to mess around with stuff. Sorry, you had a question here?
Yeah, about the cards. You mentioned the two cards. How do you tell the difference between them?
Oh, yeah, that's a good idea. Like, am I owned? Like, people ask that question a lot. So if you take out your card, some of the cards may have, it really depends on the card, but there's the traditional HID clamshell cards, which are, they're kind of like, you can see like a line around them, and then on the back, they kind of have like almost an oval back shape to them. Then usually in the back is imprinted something. And usually they'll either say like Proxcard 2 on them, and they're written like kind of right on the top. The Proxcard 2 they'll usually say on them, or they may say nothing. It really depends on that. For the I-class cards, they always, at least every I-class card that I've seen, it says I-class on it. So if you just look on the back, it'll say HID I-class. I have equipment here to determine if it's a low frequency or a high frequency card, but it doesn't really help you out too much. But yeah. Cool. Any other questions in the back? Yeah. What are the recommendations for a secure environment? Well, there's certain mitigating controls you can put in place for some of this stuff. So I've had a client. Actually, this is a pretty interesting story. So we were on site at a client, and we were doing a physical test for them, and we were trying to brute force the card values, right? And they just fired this like crazy guy employee, and they were really worried that this guy was going to try to get back in the building. So we were brute forcing these values, and just so happened to hit his card value. So they get an alert. And I don't know, I didn't know you can do this, but apparently you can set up these systems to alert on when certain cards come up. So they got an alert that this guy not only was in the building already, but trying to access the data center. So they came running at us like full force. And I was like, no! Like, you know, they just like came running out, and we gave them like the, you know, like, we're okay, like talk to your boss, we're nice. And that got out of it. But so the kind of response to the question is, you know, you can have good mitigating supplemental controls so that if you see like anything where, you know, a reader maybe is going offline, indicating that maybe somebody's trying to dump the keys out of the I-class cards. I haven't looked at some of the newer cards, so I don't know if they're better. But these cards are what they are in the presentation. Or you can set up these alerts that say, you know, if you see like 15 tries in a row, you know, maybe it's raise an alarm. Like, I don't know if you can put that logic in there, but potentially you can send like SNMP alerts or something and monitor that. Another thing somebody told me, which I totally do not believe, but I feel like I always have to say it because he might be telling the truth, is that he said in his system he set it up so that if you brute force too many times, it locks out every brute force card. So like to me that's like an immediate DOS, right? Like I mean now I can just like lock everybody out of the building like really easily. So like I don't, you know, whatever. You might be able to do that if you wanted to too. I hope he doesn't see this ever. Any other questions? Cool, guys. If you have any other questions, feel free to send me an email. Check out the GitHub, and blog.opensecurityresearch is the blog that I kind of do with. Thanks.